some while ago, I constructed this chess position, which to some extent indicates the difference between understanding and simply computation. The actual energy of the system as a whole. So there's some not quite certain element to the total energy of the system. So that's what I come to. And then I use a thing called the Heisenberg time energy principle. Now, this uncertainty principle. Now, that tells you, the usual way around is you have say, an atom which is unstable, it decays into this or it decays into this. And that atom has, because of the lifetime, it decays after a certain average lifetime. And that average lifetime is reciprocally related to an energy uncertainty in the nucleus. So I'm using that the other way.
What is a decision? What is the neurophysiological basis of a conscious decision? How can a brain make a decision about the brain? How do involuntary, non-conscious decisions be made? These are questions posed by Max King 9593 in a response to my recent video on my Analysis Cloud YouTube channel, entitled Quantum Collapsing Brains. All references are supplied in the description to this video. A decision is a quantum mechanical action. The process whereby a conscious decision is made uses unconscious quantum decision helping processes. The quantum choosing process provides the human with millions of options to consider. Due to the knowledge already retained in the brain, i.e. memories, those options are informed by those memories. The collapsing microtubules, required to force atom positions to become determinate, are part of the process whereby those options are reduced and one becomes the most probable. At that stage there are, also, some secondary, third, fourth options and so on, generated each with a weaker signal. Those options become observable to the human because their signal strength is strong enough. That strength is the accumulation of atoms becoming determinate which, in turn, created neuronal signals detectable to the human. These options, in turn, become memories. That is, the next time the human needs the same or similar decision made, those options already exist and will be used in that quantum probability process again. The generation of strong enough neuronal signals, electrical potential depolarization, is the result of an electrical feedback process. The threshold is at the point where the human becomes aware of those options becoming generated. When you think of a problem, your focus becomes your brain. That is, you think about your brain and visually imagine the problem. If you want to think about how to design a bridge to cross a ravine, for example, you would imagine the ravine. You would imagine the type of stone in that ravine and whether it is solid, sandy, and so on. You would imagine the height of the ravine. You would imagine the material of the bridge. Then you would imagine the engineering principles relevant to spanning that particular size of gap. For example, you would imagine a suspension bridge and see it in your mind's eye in that ravine. All of this thinking requires unconscious quantum decision-making happening at the rate of trillions of events in millionths of a second. When it comes to deciding on a suitable bridge design, you have a few visualized options in your mind's eye to choose from. You cannot consciously control the quantum decision-making process. The process of you imagining a new bridge design involves a feedback process into and out of your memories, which in turn creates more memories, ideas. The quantum collapsing processes aids the generation of new ideas. New ideas become memories because the next time you think about the same problem, you remember your previous attempts to imagine a new bridge design. An interesting possibility in the future is that two human brains could be connected, thus increasing the memory for both humans and thus providing for more options to the quantum process. If many human brains could be networked, then this would generate a far more informed decision. Once an artificial quantum brain has been created and connected with all human knowledge, it won't just make informed decisions like ChatGPT. An artificial quantum brain will provide for a decision-making process that examines trillions of options all at once. Qubits and microtubules. A microtubule is the organic infrastructure that utilizes qubits. The theory, known as orchestrated objective reduction, OR, was proposed by physicists Sir Roger Penrose and anesthesiologist Stuart Hameroff. It suggests that quantum computations, which could be akin to qubits, may occur within the microtubules of brain neurons. Orch OR is the most rigorous, comprehensive, and successfully tested theory of consciousness ever put forth. From a practical standpoint, treating brain microtubule vibrations could benefit a host of mental, neurological, and cognitive conditions. Thanks for watching this video, and I hope you not only enjoyed it, but have learned something new. Please do provide your ideas and thoughts about the topics raised in this video. The more we talk about quantum computing, consciousness, and quantum brain processes, the closer we, as a human race, will get to solving these problems.